All right, so we are on episode 1, still on episode 1, part 7, under binary operation, and we are discussing about properties of binary operations, and we are dealing with associative property. So anytime you are given a binary operation question to be solved and you are asked of associative property, this is the condition, and it states that an operation triangle is said to be associative on this condition: A triangle B into brackets B triangle C. On your right hand side, then the A and B will be put in a bracket, leaving your C outside the bracket. So at the end of the day, after solving your left hand side and solving your right hand side, we are expecting that your right hand side, your left hand side, and your right hand side answers being the same, then the operation is associative. So this is the condition for associative: A triangle into brackets B triangle C. On your right hand side of the equation, then you are putting A and B in a bracket like this. Then you put the C outside. In that case, then you are testing for associative property. For you to understand better, let's consider P star Q star R. If I want to say that this is associative, then it's going to be the same P star Q star R. So what it means here, so this is the challenge. This is the challenge. P star Q star R. You are going to put the same thing to your right hand side. P star Q star R. Now the difference is when you put your bracket in your first two, when you come to your right, you are going to introduce your bracket to your last two. In that case, you say that the operation is associative property, or you are dealing with associative property. And let's look at one or two technicalities here. With the associative property, one of the indicators is when there's operation sign you are seeing outside, the same operation sign will be seen inside. In that case, this is called associative property. When you come to your right hand side, the same star outside, you are going to see the same star inside. In that case, this becomes what? Associative property. But my challenge here is when you introduce your bracket. So if I'm choosing this, when I introduce my bracket here, meaning when I come to the right hand side, then I'm going to introduce my bracket to my first two. You see how the tricks works? Very good. So in that case, if you introduce your bracket to your last two numbers, meaning when you come to your right hand side, you are going to introduce your bracket to your first two numbers. In that case, you are testing for associative property. Very good. Very good. So now we get a clear picture on associative property. But let's look at this example one. Always I said, when you want to learn this word, please get a textbook, open to binary operation, associative property. I'm explaining into detail. After I'm done, use your questions in your textbook. Try if you can solve. In my very question here, an operation star is defined blah 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 blah. So it has been defined, star has been defined this form, and I'm asked to show that this 3 star blah 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 is associative. Very good. You put your solution down, then you start your statement by saying, for you are making an argument here. So you said for an operation to be associative, then the condition is, what letter did I use here? We are using M and N. Then I'm going to use the same letters to form the condition for associative property. So I will say that M star N star, let me add another letter, P. Because with my case here, I'm giving two numbers. But with associative property, we solve associative property by three numbers. But in the very question, I was giving two numbers. So I will introduce a third number, which the number is P here. So for M star N star P to be associative, then it's going to be M star N star P. Watch here. The difference I'm going to make here is how I'm introducing my brackets. So when you look at the given question, my bracket was to the last two. So when I come here, I will introduce bracket to the last two. What it means here is that when I come to my right hand side of the equation, I'm going to introduce the bracket not to my last two again, but rather my first two. Okay, in that case, when you write it in this way, meaning you are testing for associative property. All right, so this is the condition backing the associative property. But with my case, to show that blah 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 is associative. Okay, 3 star. I'm not going to introduce the bracket first. I'll put the numbers down. 3 star 4 star 2. For it to be associative, then I need to copy this to my right side. The same 3 star 4 star 2. To make the difference here, then I'll go straight. The bracket was introduced to my last two, and I'll bring it here. For it to be associative, then this time around to my right hand side, the bracket will be at my first two. My first two. So that the left and the right, there is going to be a difference. The bracket is to my last two, but when I come to the right hand side, the bracket is to my first two. In that case, you are testing for associative property. All right. So first, I'm going to consider the left hand side. The left hand side, this is my left hand side, and this is my right hand side. So I'm considering the left hand side. And what is at my left hand side? 3 star bracket open 4 star 2. All right. In this case, can we solve all the three numbers together? No. We have to handle what is inside the bracket first. So we are going to compare what is inside the bracket here with the formula. Then it's going to be or 4 plus 2 plus 4 times 2 against what is outside the bracket. What is left at the bracket behind is 3. So from here, I will simplify what is inside the bracket here. 4 plus 2, 6. 6 plus 8 will give you what? 6 plus 8 will give you 14. So now I'm getting the whole of what is inside the bracket as 40, because 6 plus 8, we are getting 14. So now 14 star 3. So everything has been left with what? 14 star 3. Then once the 14 star 3 has formed another binary, then I'm going to use my formula again. Which means my 3 is M and my 14 is N. So when I come here, it's going to be 3 plus my N is 14, so plus 14 plus 3 times 14, and it is true. After substituting 3 and 14 into this equation, I'm getting 3 plus 14 plus 3 times 14. So from here, 3 plus 14 will give me 17 plus 3 times 14, 42. 3 times 14 will give you 42 because 3, 4, 12, remember 1. 3, 1, 3 plus 1, 42. So in addition, I'm getting 17 plus this as well, 59. So in all, now I can say that 3 star bracket open 4 star 2 is now solved as it has been solved as the whole thing has been solved, and we've gotten our answer as 59. For this to be commutative, unless I solve the right hand side. So if the right answer comes as 59, then the operation I'm dealing with is associative. So I'm going to consider the right hand side. Right hand side. And what is at my right hand side? What is at my right hand side is bracket open 3 star 4 star 2. With this, I'm going to solve what is inside the bracket first. So I'm going to match 3 and 4 using the general formula, which is m star n equal to m plus n plus mn. So meaning my m is 3 and my n is what? 4 here. So I'm putting 3 and 4 into this. I'm putting 3 and 4, so from here 3 plus 4 plus 3 times what? 4. Everything against the star 2. When you simplify this, you are getting 3 plus 4, 7. 7 plus 12 is what? 19. So you are getting 19. The whole of this, I'm getting it as what? 19. So 19 star 2. 19. So the 19 is as a result of everything here. So I saw what is inside the bracket, evaluated, and had my everything here as 19 star what is outside the bracket. So it has formed another binary. So from here, we are going to substitute 19 and 2 into the equation here. So watch it. It's going to be 19 plus, and you said your n is 2 here. 2 plus 19 times 2. We are simplifying. We are getting 19 plus 2 as 21 plus 19 times will give you 38. So 21 plus 38, we are getting 59. So in conclusion, I can say that from my right hand side, bracket open 3 star 4, bracket close star 2. After solving this, I had my answer as 59. So what can you say about your left hand side? This is your left hand side. This is equation 2. And your left hand side, this is equation 1. So compare your equation 1. You had your equation 1, which is your left hand side, as 59. And equation 2, which is your right hand side. Finally, you had your right hand side answer as 59. So what can you say? Since the left hand side and the right hand side answers are the same, then the operation is commutative. So this is your conclusion. This will be your conclusion. Since, what was the question? Since 3 star bracket open 4 star 2 is equal to bracket open 3 star 4 into bracket star 2, and we had here to what? 59, and your right hand side, finally you have your right hand side as 59. So since 3 star 4, the same answer we are getting for your right, which is 3 star 4 star, then we can say that then the operation, what operation did I use in solving the word? I used operation star. Then the operation star is associative because the left hand side answer is the same as the right hand side answer. So in that case, the operation is associative. The operation is associative. So anytime you are asked to solve this by associative property, you put the condition down, which is m star n star p equal to the same m star n star p. What makes the difference here is when you introduce your bracket to your last term, when you come to your right hand side, you are going to introduce your bracket to your first term, and this is what I did. 3 star 4 star 2, everything the same number, is the same 3 4 2 3 4 2. The difference is that how you introduce your bracket. When you put your bracket to your last two, meaning when you come to your right hand side, it's not supposed to be at the same last two. Use your first two numbers. Are you getting it? So you consider this as your left hand side, then you take this as your right hand side. Then I'm considering my left hand side, and what is there? You is there. Then I'll put it down. Per the analysis, it tells you that you are going to solve what is inside the bracket first. I have 4 and 2. Using the formula 4 and 2, meaning your 4 is n and your 2 is n. When you substitute 4 and 2 in the formula, you are getting 4 plus 2 plus 4 to m plus n plus mn, m plus n plus mn. When you simplify everything here, you are getting 14 against the star 3, and this is the star 3. It has formed another binary operation, which my m is 3 and my n is 14. My m is 3, my n is 14. You substitute m plus n plus mn. You see that? You put it in that way, and these two will be here. When you simplify, you are getting in total, you are getting the whole of the equation 1 as 59, and you can see that. Now, 3 star bracket open, 4 star 2. Per the formula in the question, we are getting the answer to be 59. After you are done, for you to know that the operation is associative, we said that for an operation to be associative, the left hand side should be the same as the right hand side. So in that case, then I need to take the right hand side into consideration. Then I'm to solve the right hand side in such a way that if my final answer to my right hand side be the same as that of the left hand side, then the operation is commutative. So I considered 3 star 4 star, that is my right hand side, and I started solving what is inside the bracket. So using the general formula here, what is inside the bracket is 3 and 4. So whenever you see 3, you put m. Whenever you see m, you put 3. Whenever you see n, you put in 4. So 3 and 4, putting 3 and 4 in the formula, this is what we are getting. After simplifying this, you are getting everything here as 19. So it's going to be 90 against this star 2. It has formed another binary. So once it has formed another binary, meaning your m is 19 and your n is 2. So when you substitute 19 and 2 into the general formula, because once it has formed binary, then you are using the formula. You can use the formula. So 19 plus 2 plus 19 times 2. When you simplify, you are getting the answer to be 59. So it means your right hand side answer finally is now 59. So equation 1, we are getting the answer to be 59. Equation 2, we are getting the same answer to be 59. Then the conclusion is, since the left hand side answer is the same as your right hand side answer, since the answers are the same, then the operation is commutative. Any question? You can put your question or your comment on your comment section. But remember, one may ask, what if, say, after solving my left hand side and at the same time solving my right hand side, and it happens that my left hand side answer was 59, that's correct, but that of my right hand side happens to be something like, if your right hand side happens to be 42, can we say that the operation is associative? No. In this case, since your left hand side answer is not the same as your right hand side, then the operation star is not commutative. It's not associative. That means your the operation star is not associative because the left hand side answer is not the same as your right hand side answer. In that case, your conclusion is going to be the operation is not commutative. But remember, for what we discussed here, the answer was the same. We had the left to be 59, and also we have the right also to be what? 59. Then the operation star is associative. Thank you for your time with me. Please do well to subscribe for more videos. We have a lot to share with you. And remember, if you're on any platform, push it forward so that you'll be blessed. Once you've been blessed right now, let others also tap your blessing by sharing it on various platforms. Thank you for having time with me. Bye for now.